The following Zoom session is being recorded and will appear later today on my YouTube channel, Math with Mayo. Therefore, when you participate in the Zoom meeting, if you do not wish for your picture or your name to be made public, please leave the video off and use an alias name. If you have questions during the meeting but do not wish to speak, email me at bmail@ybcc.edu and I will respond as soon as I can. All right, so today we're going to look at section 6.3 again, but instead of using the factoring by grouping method that we discussed yesterday, we'll use a method called trial and check. This book calls it trial and check. I've heard it called guess and check. I've heard it called the FOIL method, all these different methods, but it's basically describing the same thing that we're going to look at. But before we do that, I want to give you the ID. This is the Zoom ID, 509-574-6827. That is the Zoom ID for the Math Center. So there is help beyond just me or the videos. You can go into Zoom, put in that ID, and it'll take you into the Math Center where there are people standing by even now to help you. And I don't recall offhand what the hours are, but if you reach out to them, I'm sure they can tell you. Anyway, all right. So having said that, we're now going to look at this trial and check method of factoring trinomials. And I'm going to start off with this one, 3x squared plus 4x plus 1. Now, just like yesterday's method, when we're trying to factor a trinomial, we want to have it in standard form or descending powers of the variable. This one is. If there's any greatest common factor other than a 1, we want to factor that out first. This one doesn't have that. So now at this point, instead of labeling A, B, C, P, S, all of that stuff, what we're going to do, we're going to look at the leading coefficient, which is 3, and we're going to write all the factor pairs that multiplied together give you 3. So in this case, 3 and 1 would be it. Okay? Then we're going to look at the last term, in this case, the constant term, and write all the factored pairs whose product is 1. Basically, it's just 1 and 1. This problem doesn't have a lot of possibilities, which is why I picked it. We'll get to more complicated ones as we go. Now what we do is we're going to write out all the possible combinations of two factors using these numbers in the first position and these numbers in the last position. So for instance, I could have 3x plus 1, the 3 here and the 1 there, 1x plus 1, the 1 here and the 1 there, okay? Now, granted, I don't need to put that 1 in front of the x, so I'd have that. Now, in this case, if we switch things around and we use the other numbers over here, since that's the same number, we'd still only get 3x plus 1 times x plus 1. And if that seems confusing, wait till I do one that has different numbers. Anyway, this is the only way that this thing could be factored, okay? Let's look at another one that's a little bit more complicated. Let's see here. Okay. 15a squared minus 28a plus 5. This is a trinomial. It is in descending powers or standard form. There's no greatest common factor. It doesn't have a negative coefficient up front, so we wouldn't factor out a negative. So factor pairs that multiplied together give you 15 would be 15 and 1, 5 and 3. Then we look at the last term, the 5. Factored pairs that multiplied together give you 5 would be 5 and 1. However, notice that the middle term is negative. So in fact, we're going to have a negative 5 and a negative 1. Okay, let me write that a little bit better here. So a negative 5 and a negative 1. Okay. Yeah, what am I doing? Sorry. Need parentheses there. All right. So now the group over here, those numbers are the leading coefficients of the first binomial factor, these numbers would be the last term in those binomial factors. So I've got 1, 2, let's see how many combinations. Well, I could have 15a and 1a and -5 and -1. Or I could have 15a and 1a and -1 and -5. Or I could have 5a and 3a and -5 and -1. Or 5a and 3a and -1 and -5. So these are the different possibilities. Now again, what have I done? I've taken 15 and put it with -5, and 1 and put it with -1. Then I've taken 15 and put it with -1, and 1 and put it with -5. So switching them around. Same thing, 5 goes with -5, 3 goes with -1, or 5 goes with -1, and 3 goes with -5. So all those different combinations, okay? Now, every one of these pairs of binomial factors, if you multiplied them together, you'd get 15a squared up front and +5 at the end. But the middle term, the -28a, that's what we're looking for to get the correct answer. So let's see here. That would be what? -15a minus 5a would be -20a, so it's not that one. This would be -75a minus 1a, that's -20 or 76a, so it's not that one. This would be -5a minus 15a, which is -20a. And finally, this would be what? -25a minus 3a. Aha, -28a. Now, I didn't deliberately set this up so that the correct answer was the last one. I really didn't. That's just how it worked out. But this one here, multiplying together, gives me the 15a squared minus 28a plus 5. Okay? Now, this method can be rather tedious if you're writing out all these possibilities. So why would somebody want to do this? Well, if you can do this process in your head without having to write everything out, then it's not so bad. So let me look at what I mean by that. Okay. So I had 15 and 1, 5 and 3, -5 and -1. Okay. Rather than going to all the trouble to writing them all out like this, I'm going to try to find -28a in the middle. So I'm going to take 15 times -5, which is -75, plus 1 times -1, which is -1. -75 plus -1 is -76. So it's not that combination, all right? Well, now I'm going to take 15 and I'm going to put it with -1. And I'm going to take 1 and put it with -5. Well, 15 times -1 is -15. 1 times -5 is -5. -15 plus -5 is -20. So we've just determined that it's not those. Okay? I'm going to rewrite those without all the extra lines. So let's take a look here. All right. 5 goes with -5 and 3 goes with -1. 5 times -5 is -25. 3 times -1 is -3. -25 plus -3 is -28. Aha! So I got the right combination. So now I know I've got a 5a and a 3a, but I took 5 times -5, so that -5 has to be over there in order to be multiplying by. Okay? Is this making any sense?
Yes.
Okay. All right. Let's take a look at another example. 4b squared plus 15bc minus 4c squared. This is a trinomial. It's in standard form in terms of b. There's no greatest common factor. The leading coefficient isn't negative. We're going to use this trial and check method. So 4 could be 4 times 1 or 2 times 2. -4 could be -4 times 1, -1 times 4, 2 times -2. Negative 2 times 2 would be the same combination. All right. So we need to take one of the first numbers times one of the second numbers plus the other of the first times the other of the second until we come up with a plus 15. Okay. Now, if I take this number times that number plus this number times that number, 4 times 4 is 16. 1 times negative 1 is negative 1. 16 plus negative 1 is 15. Aha. So that means I've got to have a 4b and a 1b. And the 4 was multiplied by the 4, so plus 4 minus 1. I'm missing one detail. What is it that I'm missing? That was interesting. I'm missing the c. Okay, because it's c squared. But anyway, so 4b minus c, b plus 4c. And again, how did I get that so quickly? I looked at these numbers and those numbers, and I said, I need one of these times one of those plus the other times the other, and come up with 15. Okay. And so I was able to spot that. Now, if you can't spot it looking at it, if you're going to have to write out, let's see, there would be 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 7, 8, 9. I think there's like 9 different possibilities here. So if you have to write those all out in order to find the correct one, you're probably not going to want to use this method. But if you can look at it and see, you know, how to get the 15, then this method isn't too bad at all. Okay. Let's take a look at another example here. 16r minus 40r squared plus 25r cubed. So the first thing I need to do here is put this in descending powers or standard form. 25r cubed minus 40r squared plus 16r, excuse me. Then I'm going to take out the greatest common factor, which is an r. So I get r times 25r squared minus 40r plus 16. So everything's the same up to this point, regardless of which of the two methods we use. But now, let's see. The 25 could be 25 times 1 and 5 times 5. The 16 could be 16 and 1, 4 and 4. Oh, but the middle term's negative, so these would have to both be negative. Oh, and I left one out, didn't I? Negative 8 and negative 2. Okay. So I've got all the factor pairs that multiply together give you 25. All the factored pairs multiplied together give you 16, but they have to both be negative because our middle term is negative and our last term is positive. Okay. So I'm looking for negative 40. Well, let's see here. Oh, how about this? 5 times negative 4 is negative 20, and 5 times negative 4 is negative 20. Negative 20 and negative 20 is negative 40. So I've got r, don't forget I've got that r from the outside, 5r minus 4, 5r minus 4. Or you could write it as r times 5r minus 4 squared. Okay, so again, I was looking for a negative 40 by taking one of these times one of those plus the other of those times the other of those. Okay, and I just looking through it, I could see that, oh, this one was going to be really way too big negative. And again, if you can spot it there, this method works quite well. Let's take a look at another example. This is, let's see here, 8m squared plus 5m minus 10. It's a trinomial. It's in standard form or descending powers. It has no greatest common factor. The leading coefficient is positive, so we're good to go. Let's see. 8 could be written as 8 times 1, 4 times 2. Negative 10 could be written as negative 10 times 1, negative 5 times 2, negative 1 times 10, negative 2 times 5, all the different combinations. But I'm trying to come up with positive 5. Okay, so I'm looking for a pair over here and a pair over there, and taking one of the first times one of the second, and then the other of the first, and then if that doesn't work, switching them around. But I want to come up with a positive 5. Okay, so for instance, this times this would be negative 80 plus 1 is negative 79. Or 8 times 1, 8. 1 times negative 10, negative 10. 8 plus negative 10 is negative 2. Okay, now, unfortunately, I can't eliminate either one of those groups because I've got other possibilities to go. But let's see here, 16, 5, 40, that's not going to work. 24, 20, let's see here, 10 and 8, 20 and 4. Boy, I'm not seeing any, and so I want to be really careful that I don't miss any, okay? So I'm going to go ahead and write these all out, as tedious as that may seem. So I'd have 8m, 1m, minus 10 plus 1, 8m, 1m, plus 1, minus 10. Again, do you see where I'm generating those factor pairs from? Are you clear with where that's coming from? Hopefully, yes. Okay, now I'm going to take this group with this group. 8m, m, minus 5 plus 2. 8m, m, plus 2, minus 5. This group with this group. 8m, m, minus 1 plus 10. 8m, m, plus 10 minus 1. Then with this one, 8m minus 2, m plus 5, 8m plus 5, m minus 2. All right, so that's just those first two with all of that, and I've got 8 possibilities. But if we look at those, none of them give me 5m in the middle. This is 8 minus 10 is minus 2, minus 80 plus 1 is minus 79, 16 minus 5 is 11, negative 40 plus 2 is negative 38, 80 minus 1 is 79, negative 8 plus 10 is 2, 40 minus 2 is 38, negative 16 plus 5 is negative 11. So it can't be that one. So it would have to be the 4 and the 2. Okay, so let me do this. So I don't have to go to a new page. Okay. So I've got 4m and 2m and minus 10 and plus 1. 4m and 2m and plus 1 and minus 10. 4m and 2m and minus 5 plus 2. 4m and 2m and plus 2 and minus 5. Let's see here. 4m and 2m and minus 1 plus 10. 4m, 2m plus 10 minus 1. 4m, 2m minus 2 plus 5. 4m plus 5, 2m minus 2. And let's see, this is 4 minus 20, that's not 5. 40 minus 2, that's not 5. 8 minus 10, negative 2, that's not 5. Negative 20 plus 4, no, 40. Guess what? It's prime. Wow. A lot of work, huh? Now, I could have still just done that by, looking at the numbers and not writing them all out, but I was feeling a little insecure, like, well, gee, maybe I missed something. In which case, boy, looking at all of them, and that's only half of them, right? I deleted the other half. Okay. So this second method, it works well when there aren't a lot of different combinations. When there's a lot of different combinations like this, then I'm not convinced that it's a better way to go than the other way. But what I want you to do in tonight's homework is I want you to use this method, okay? Now, granted, WebAssign won't know which method you use because all you're going to put in is the answer and you should get the same answer either way. But the reason I want you to practice this method and use it is because you may decide that you prefer this method over the grouping method, or you may decide you prefer the grouping method. It doesn't matter to me ultimately which method you use, but I want you to practice this method so that you'll at least know whether you like it or not, okay? Oh, let's see here. I think that's all I've got for you. So for tonight, for the weekend, I'm going to go ahead and stop the recording here.